Association. Let me put this in presentation mode. There you go.
Thank you. Good afternoon, everyone. My name is Daoqing Liu. I'm from World Steel Association, and I'm from China Baowu Steel Company, and I'm now a fellow in World Steel Association. And today, my presentation mainly include 4 parts. The first, I will introduce steel and carbon emission, the relationship. And the next, I will introduce the CCUS technology and the matching ability or degree between CCUS and steel production, and the opportunities and the challenges for the CCUS deployment in steel. And the last is I give you summary and outlook. The first, I want to introduce the carbon emission in steel industry. And we think the industry sectors is the main emission source of CO2. And most CO2 emissions are from the use of fossil fuels. And the steel industry contributes about 7.2% of the global greenhouse gas emissions. And also embedded global carbon emissions from the steel industry. And more than 1/3 global carbon emissions related to steel production are reflected in international trade. And many developed countries are net importers of steel carbon emissions. And I just a brief introduction to iron steel making process. And there are 3 main routes for steel production. And the first is primary steel production, mainly by blast furnace and BOF process. About 72% steel produced by this kind of process. Second is the DRI EAF, is a direct reduction iron and EAF. And the third route is secondary steel production, mainly by scrap steel and EAF. And in steel production process, coal can be used in 2 ways. And the first is as a power source, and second as raw material. But for different steel production process, the CO2 emission intensity is different. And according to different institute, the average CO2 emission intensity for traditional steel production process is about 2.2 ton CO2 per ton crude steel. This is the 3 main routes of steel production. And this is the CO2 emission from typical steel production. For different process in steel production, the CO2 emission is different. But for the traditional, this is the traditional long steel production process. The total CO2 emission is about 2.15. But for different companies, this data may be different. And the next, we'll talk about CCUS. You all know about CCUS, but CCUS actually includes CCS or CCU. And what we should choose, CCS or CCU. In broader terms, in this conference, we mainly talk about CCS. But in China, now we are doing CCUS work. But CCU is more talked by all the steel companies and experts in the universities. In contrast, CCU compared with CCS, CCU mainly talk about how to transmit CO2 to other products, such as methanol and alcohol and other chemicals. And next, I will introduce the CCUS technology. compatibility and application potential in steel industry. This is the carbon capture technology. There are different carbon capture technology, but with different potential and also compatibility with steel production. Here, this chart shows the compatibility of CO2 capture with steel industry, and the different colors represent a different CO2 capture potential, which this pink color have the highest potential, and followed by blue and yellow with the lowest potential. The horizontal axis represents the maturity of technology, with higher values indicate higher maturity. This graph shows the carbon dioxide chemical and biological utilization technology, which we call CCU utilization technology. And different colors also represent different CO2 reduction potentials. Pink have the highest potential, and followed by blue and yellow with the lowest potential. This graph shows the carbon dioxide geological utilization and storage technology. And this is different from CCS. We often say the geological utilization mainly usually include geological sequestration and EUR or EGR. But in this conference, experts talked about geological sequestration only storage. But in China, this EUR or EGR is used for long times. But geological storage, we just begin to do this work. And this paragraph just shows the CO2 capture and geological utilization of EUR in the steel plant. The right chart shows the distribution of steel companies, which is the CO2 emission sources, and the potential CO2 sequestration sites, which is the CO2 sinks. From this paragraph, we can see obvious source sink mismatch problem. So Chinese steel company mainly concentrated in the eastern coastal region, but potential sequestration sites mainly heavily distributed in the Midwest region. From this graph we can see. And I want to say in the past few years, we often talk about CO2 emission reduction, so from the emission reduction perspective. But now we should repositioning of CCUS technology. We should, from a carbon neutral perspective, how to say, CCUS should be a key role, play a key role in the future industrial decarbonization, especially for energy construction. CCUS technology is the only way for large-scale low-carbon utilization of fossil energy, such as coal power plant. And also power system. Flexibility and zero carbon emissions must be met for the use of fossil fuels. And equipping thermal power plants with CCUS is an important way to ensure the flexibility for the power grid in the future. And also for hard-to-abate sectors such as steel company, development of negative emission technologies is needed in the future. And the CCUS technology is a crucial guarantee for achieving carbon neutrality in the future. And this is the chart shows from 2020 to 2050, the CO2 reduction by different paths in steel sectors. before 2030, the main decarbonization ways should be material efficiency improvement and technology performance improvement. But after 2030, till 2050, CCUS will play more and more important role in steel decarbonization. And from IEA and China Academy Science, from IEA, CCUS will contribute about 16% emission reduction on the sustainable development scenario. And according to CAS prediction, the CCUS will account for about 32%. So this is different. And this will introduce CCUS technology deployment status in the world. In the first half of 2023, CCUS commercialized projects continue to increase. And from this table, geological storage has become the primary method of carbon utilization. And in the past, mainly for EOR or EGR. But in the future, geological storage become the primary method. And 70 of newly development of current development commercial projects use the geological storage. And DAC will continues to create history. And the voluntary carbon emission reduction market has attracted increasing international attention. And a brief introduction to CCUS deployment in China's steel industry. In 2018, Chinese Sougang Steel built the world's first steel tail gas biological fermentation industrial devices and put into operation. This is similar with the ArcelorMittal Ghent plant to use blast furnace gas to produce methanols and alcohols. And in June 2022, China's steel industry first full-chain CCUS demonstration project began to construction. The scale is 2 million tons per year. The first phase is about 500 K tons. And in November 2022, China Baowu signed a MOU with Shell, Sinopec, and BASF to launch an open-ended 10 million ton CCUS project. And give a brief summary of the CCUS deployment challenges, mainly high cost, and second is high energy consumption. And the third is high security risk. And this I want to say CCUS for the public perception. The safety, because CO2 storage relates to high pressure treatment of CO2, long distance transportation, and underground storage. So the public is mainly concerned about the safety problems, such as CO2 leakage and pipeline rupture and earthquake, etc., and which may have serious impacts on human health and ecological environment. And the fourth is lack of policies and regulations. And I think this is the common problems to China or also the other countries. The last, I want to give a brief summary and outlook. I will say CCUS is the main technical means to achieve large-scale zero-emission utilization of fossil energy and maintain power energy flexibility. So CCUS is a necessary solution for hard-to-abate sectors such as steel, non-ferrous metals, chemicals, and cement, etc. And the CCUS technology has made great progress in the past years and is increasingly deployed in the global. The deployment of CCUS will face many challenges such as technology, security, cost, and policy. So if you want to, we want to promote the large-scale deployment of CCUS technology. It is necessary to strengthen technological innovation and cost reduction and improve energy efficiency and safety performance, improve policies, regulations, and also market mechanism, and strengthen international cooperation and experience change. Thank you.
We'll keep the questions for the panel session. Our last